So, good morning, everyone. My name is Denis Torres. Thank you for attending this session on Dataset Pordenone. I'll be talking about Data Lakehouse in the cloud, the Azure solution for Data Lakehouse. So, thank you for the sponsors of this conference. Without the sponsors, this conference would not be happening. And this is me. I'm a data platform MPP trainer with some certifications. I live in Malta. I'm the leader of Malta Data Platform User Group. And you can see on the screen my contacts. Feel free to stay in touch. It will be a pleasure to keep in touch. So the agenda today. We'll talk about data warehouse, big data, data lakehouse, and the Azure solution for this area, all these features. And we'll also talk about virtual data lakehouse and see a demonstration. So let's start talking about the data warehouse. And when I say data warehouse, many of you may be thinking, oh, this is too old-fashioned. This is something from last century. We don't talk too much about data warehouse anymore, and so on. That's not totally true. That's not totally true. The data warehouse works very well as a single source of truth for the companies, for a corporation. A corporation needs a single source of truth. Without a single source of truth, like a data warehouse, tools such as Power BI or other serving tools would have trouble to find trustworthy information, to get trustworthy information. So data engineers and data architects work hard to build a data warehouse environment and make it a single source of truth for the company. It doesn't mean that a serving tool like Power BI, for example, will not get data from other sources as well. Many times and for many reasons, a serving tool will need to get data from other sources, and we will talk about that. But still, the data warehouse can work as a single source of truth. And it uses the star schema that this is not so old-fashioned. You use you use a star schema also when building a semantic model in tools like Power BI, for example. So this is not so old-fashioned. What makes it different nowadays and makes people think it's old-fashioned is because the data warehouse is not alone anymore. Many years ago, the data warehouse was the core of the data platform, but nowadays it's not alone. Now it has some friends, and one of these friends is the big data. The idea of the big data is when production provides us with such a huge amount of data and so fast that we can't receive this data in a relational environment. So the amount of data is too huge and the data arrives too fast. For example, imagine if you build a mobile app and you collect data about how people is using your mobile app on a worldwide distribution. It's too much. It's too much data. So that's what we call big data, and this doesn't fit in a relational environment. So we need an ingestion process to receive a big data, data like big data. So an ingestion process, there is an architecture called Lambda architecture, and you can use a Lambda architecture, or from this Lambda architecture, there are many variations. Many variations of the Lambda architecture are possible. It starts with a feature to ingest the data, to receive the data and ensure that you will not lose anything. In Azure, this feature is the Event Hub. The Event Hub makes the ingestion on a Lambda architecture. Then the data is distributed to two different layers. The same information goes to two different layers, the batch layer and the speed layer. Why two? Why two different layers? Because one of the layers will store the data. This is the batch layer. So we'll keep a history of the data that we have. The other one will work to provide us with a real-time information. Every time we receive requests from managers and directors to see how is our business going now? What's the status of our business now? So we need to provide real-time information. That's what the speed layer is capable to do. On the speed layer, we use string analytics. String analytics is capable to aggregate the data and remove redundant records, and then it provides the final information, an information better to be consumed to a serving layer. The serving layer can be, for example, Power BI. Power BI works very well as a serving layer for real-time data on this architecture. On the batch layer, we store the data. This example is illustrating Data Factory as an ETL tool and Azure Cosmos DB for storage. But we may also store the data on Azure Data Lake storage. It's even more common to store the data in an Azure Data Lake storage. And Power BI can work as a serving layer as well to show historical data, to show dashboards with historical data. So Power BI can be a serving layer for real-time data and for historical data on these examples. But especially for the batch layer, with the data stored in, let's say, Azure storage account, we'll make a further process of this data. We'll process the data in many different ways. So, to process an environment with big data, it's very common that we use the MPP architecture, Massive Parallel Processing Architecture. In this architecture, and I'm talking about architecture because many products implement this architecture. For example, Synapse Analytics, Spark, Databricks using Spark implements this architecture. SQL Server Big Data Cluster implements this architecture, although unfortunately it died yesterday. Yes, no, I'm not sure if everyone is aware about, but Big Data Cluster died yesterday. That's true. So we use MPP to process big data. What's the idea of this architecture? The idea is that the application or user will connect and send queries to a control node. This control node will break down the task to process the data among many compute nodes. This task to process the data will be broken down among many compute nodes. Each compute node will process a piece of the data and return the result to the control node. The control node will join the result and return the result to the end user. The result goes back to the end user or end application. Then, going back to our friends, data warehouse and big data. When we talk about big data, we are talking about the data itself. The data is a huge amount of data which arrives very fast. Okay. But where this data will be stored? The place where this data is stored brings to us another name to the scenario, the name that we call a data lake. Why we call a data lake the place where we store the big data? Because like a lake, the water is is doesn't move too much. The water doesn't stay if the water stay calm, doesn't move too much. That's the idea of the big data. The big data is stored in the data lake and it will not move because it's a very huge amount of data. So we will not be moving this data. This is a difference when compared with how we manage data many years ago, or maybe even last century. Because, for example, oh, we need to use the two-way to process our data. So move our data to the two-way to the software A and the software who processes the data. And then after some time, oh, we need to use software B to process our data. Move the data to software B and software B will process our data. And so on. So we keep migrating the data from one point to another to have different results according to the software which is processing the data. We don't do this with a data lake because the amount of data is absolutely huge. So we simply don't do this. So what we do? The data lake, on the data lake, the data is there, static, waiting for some tool to read the data on the data lake, get the data that that tool needs, and process the data. So the data doesn't move to the tool, doesn't go to the tool. It's the tool that goes to get the data in the data lake. This makes the difference between the data lake and all the data storage from the past. And we need to take care about the quality of the data. So otherwise, our data lake becomes a data swamp. We need to take care about the quality of the data. So data warehouse works with structured data. The truth is that this is not exactly the theoretical definition of the data warehouse, but nowadays we consider like this. Data warehouse is the work with structured data, relational data, while data lake works with unstructured data and big data. So both of them decided to marry, they had a honeymoon, and suddenly we got the data lake house. A data lake and a data warehouse working together. The data lake house. We are talking about data, but a data lake house is not about one storage of data or one format of data. Data lake and data warehouse are still two kinds of data stored in different places. One in relational environment, another in a data lake environment. But the point of a data lake house is to have a tool capable to process both. So the data lake house, the name data lake house talk more about having a tool capable to process both together and to create relations between both, between the data house and the data lake. So we have structured data, unstructured data, and big data, and the data lake house will work with all of them. Let's talk about the Azure solution for this, Synapse, the Azure solution for the data lake house. So we have Azure Blob Storage. Azure Blob Storage in Azure is also called Azure Data Lake Storage. There are some technical details about the difference of the name, but let's not dig on this. So our data lake will be in an Azure Blob Storage. Then we can use a non-demand SQL pool to process the data lake on an Azure Blob Storage. A non-demand SQL pool is a pool processing pool which exists inside Synapse Analytics. So we can use this SQL pool to process the Azure Blob Storage. And Synapse Analytics also has a dedicated SQL pool capable to process relational database. Isn't this like Azure SQL? No, this is not like Azure SQL because the dedicated SQL pool uses MPP, massive parallel processing, the architecture that I mentioned to you before, over a relational database. So our SQL queries are broken down in many pieces and processed by many different nodes inside the dedicated SQL pool. The dedicated SQL pool and the on-demand SQL pool can talk to one another, can relate to one another. And then we have a Spark pool. Using Python, we can process our data lake as well. So in fact, we even have a choice of tools. We can process our data lake in this scenario using a SQL on a SQL on-demand pool or using Spark on a Spark pool. We have options for that. The Spark pool and the SQL on-demand pool can share information on a common database. They use a common database to share information between them. And in this scenario, we have the Spark pool and the on-demand SQL pool making tasks over a data lake. And we have the dedicated SQL pool making tasks over a data warehouse, over a big data warehouse. So we have data lake and data warehouse together. A data lake house. That's the idea. One tool capable to process both together, capable to process data warehouse and data lake together. So let's compare this with the classic data warehouse solution. A classic old data warehouse solution would have a data source, our production data source. Then we would use ETL, also cleaning the data during the ETL to feed the data warehouse. So we would feed the data warehouse using an ETL from production. From the data warehouse, you will build a semantic model. So the semantic model becomes easier to the end user to consume the data. The data warehouse needs to contain all the historical information. Many times we need to use, for example, dimensions type 2, and the end user would not work very well with these models. So we build a semantic model for the end users to work better with them. And from them, either from the data warehouse or from the semantic models, we build reporting and analysis that the end user will consume. This is the classic data warehouse solution. Let's compare this with also our data lakehouse solution. So what's the comparison here? On our classic data warehouse solution, we can say that the data warehouse, in fact, is becoming the data lakehouse. The ETL is going to inside the data lakehouse and not anymore the data warehouse, not only the data warehouse, but the data lakehouse. Of course, is going to inside the data warehouse piece of the data lakehouse. We have production. We use ETL tools like Data Factory mapping data flows, and ingest the data it's pointing to the data lake, but this data will be ingested inside the data warehouse piece of the data lake house. At the same time, the data lake house will be ingesting big data as well. So you have big data arriving from Event Hub, from IoT hubs, summarized by Stream Analytics and stored in an Azure Blob Storage, and being available to be processed by a SQL on-demand pool and a Spark pool. So in this way, you can compare these solutions, the classic data warehouse and our data lakehouse solution. Let's talk now about the serving layer. The layer that will show the result for the end user. In this case, Power BI. Let's talk about the solution architecture related to Power BI. Power BI uses data flows. Power BI can consume data using data flows. It uses the data flows to load the data and transform the data. The transformed data goes to a shared model. We can also call this shared model as cubes or semantic model. So the data flows result in data sets, and the data sets are semantic models. The data sets are semantic models, and from the semantic models, we build our reports in Power BI. The end result for our users, the reports that we have in Power BI. How this fit our architecture, our data lakehouse architecture? Power BI will use the data lakehouse as a source of data, and the data flows will be consuming data from the data lakehouse, either from the data lake or from the data house. Will be consuming data from this single source of truth. Of course, the data flows, data sets in Power BI can get additional external data. They will not keep only reading data from the data lakehouse. They can get additional external data. That's why DTL solution in Power BI is called self-serve DTL, because the users can get additional external data using the Power BI tools. And this helps a lot the IT team, because the IT team doesn't stay overwhelmed with requests from the users. Please add one field here. Please add one table here. Please add an additional data here. So the IT team built the data lake house, but the users are capable to get additional information that they feel are missing on the data lake house by using Power BI. So why we have two ETLs on this scenario? What I'm talking about having two ETLs on this scenario, because we have the data factory as an ETL on this scenario, and we also have data flows as an ETL on this scenario. So why do we have two ETLs on this scenario? The data factory and the Power BI data flows. These are the two ETLs I'm talking about. So the data factory delivers the data to the data lake house, more specifically to the data house piece of the data lake house. The data lake house is for all the historical data. All the historical data, the single source of truth of the company. The data flows, on the other hand, deliver the data to the data sets and usually use the data lake house as a source, although they can use other sources as well. And the data sets are the semantic model, closer to the user and easier for the user to understand and to build self-service solutions from the semantic model. That's the idea. And getting back to our classic data warehouse solution, where Power BI fits on this classic data warehouse solution? Power BI is replacing the old tools that we used to build the semantic models and build the reporting. The semantic models and the reporting can be built by Power BI. But note on this drawing that Power BI doesn't replace the data warehouse or the data lake house in this situation. In fact, the data lake house is the source of data for Power BI. What do Power BI is replacing in this scenario? In the past, very distant past, we were used to use SQL Server analysis services to build semantic models, and now we use Power BI to build semantic models. And we were used to use reporting server to build reports, analytical reports, and now we use Power BI for that. In fact, the features on reporting server were incorporated inside Power BI. So let's talk a bit more about scenario in a big corporation. So we have a main office, and from this main office we have branches in Europe, North America, and Asia. And on each continent we have branches in different countries, in different places around Europe and the continent. Sardinia, Malta, United States, Mexico, Russia, China, and so on. So we have an enterprise IT department on the main office and some of the main continental branches. And we have local departmental IT on each country branch. For sure, each departmental IT will build their data solution way before the enterprise IT goes for it. So when the enterprise IT decides to build their data solution, when the enterprise IT decides they are ready to build their data solution, each departmental IT on each country may already have their own solution. Some of them may have data warehouses, some of them may have data lakes, some of them may even have data lake houses. So each departmental IT will have their own solution on this situation. So what happens? How the enterprise IT will build their solution? The corporate intelligence in this case, how they would build that? Would they use ETL solutions to import the data from the departmental IT? This makes no sense. This even breaks the concept of a data lake. If a departmental IT already built a data lake, the idea is that the data will not be moved. The data will stay there where it's saved. The data will not be moved. So using ETL to import data from a data lake even breaks the concept of data lake. So they should not do that. What they should do, access the data in place. Make remote access to each data solution on each branch, each country branches. So from a single place, from a single tool, they can access remote data, they can merge remote data, and then to make this data easier for access, they can create summaries, they can create aggregations of this data, and these aggregations can be saved on the corporate side of the database. That's the idea of a virtual data lake house. That's why we have the name of a virtual data lake house. When You already have data solutions spread around a big corporation, and you need to build a central data solution. You not broke down existing data solutions. You read from them remotely. So you are creating this scenario a virtual data lakehouse. The idea is that these tools are capable to access the data using the cloud. Remote data. The SQL on demand and the Synapse dedicated pool are capable to access remote data and bring remote data to be processed on this place. The idea of virtual data lakehouse. And besides that, we also add to this drawing the machine learning. Of course, we have machine learning tied with Power BI. Power BI can make application of models. We have machine learning linked with the data lakehouse. Synapse Analytics has links with machine learning tools and can process machine learning models. So we have machine learning included in many of these steps. So machine learning is also included on this scenario. Then let's talk about the tool that we use on Azure to build this scenario, this data platform scenario. Let's talk more about Synapse Analytics. To explain Synapse Analytics, let's use this old picture from the 80s. You may remind this old picture. This old picture is displayed around Facebook, around the internet as a joke. Because everything this guy is using here on this picture is replaced by a simple cell phone. A simple cell phone can complete all these tasks. And that's the idea of Synapse Analytics. Synapse Analytics is joining different tools in a single working environment. We can have a single working environment to build all this data platform. The idea is to stop the alt tab or the need to learn completely different tools. So you have one tool to focus on, Synapse Analytics. You focus on Synapse Analytics. It's like a switch plate capable to do many different tasks. And how Synapse Analytics manage this? Synapse Analytics manages this by joining different tools, and many of them already existed in the market, or creating links to other tools, or incorporating tools or creating links to other tools. For example, Data Factory. Data Factory was incorporated inside Synapse Analytics. We still have Data Factory that we can use in an isolated way inside Azure. But we have Data Factory inside Synapse Analytics. So, in fact, we have now two data factories. The Synapse Analytics Data Factory and the Azure Data Factory. So we have the pipelines for the Data Factory to build GTLs. Azure SQL Data Warehouse. Before Synapse Analytics, Azure SQL Data Warehouse existed as an isolated product. Azure SQL Data Warehouse was incorporated inside Synapse Analytics. And now we call the old Azure SQL Data Warehouse as the Synapse Dedicated Pools. The Synapse Dedicated Pools are the old SQL Data Warehouse. The Spark pools, so we can use the Spark pools inside Synapse Analytics. Power BI. Power BI is linked to Synapse Analytics. From the same work environment of Synapse Analytics, we can work with Power BI as well. And Azure Machine Learning. Azure Machine Learning is linked to Synapse Analytics. From the same environment, we can work with Azure Machine Learning as well. So this other drawing also illustrates a bit Synapse Analytics. So we ingest the data using pipelines. For example, the storage can be relational, can be an Azure Data Lake, Gen2, Spark Tables, CosmoDB, and the SQL provisioner tool, the SQL dedicated pool, SQL on-demand pool, and Apache Spark tool will be processing this data on this storage, while Power BI will work on the serving layer, providing the results for the end user. Let's see a demonstration about all this. So I have here a Synapse, what is called in Azure a Synapse workspace. Synapse workspace. This Synapse workspace has some pools, like we call them, like SQL pools. I have dedicated pools, and I have the built-in pool, which is the on-demand pool, which is serverless. Apache Spark pools. So there is a Spark pool here available. So we have pools that we can use to process our data. And to work with the Synapse environment, we use a tool called Synapse Studio. So we can use Synapse Studio to work with this environment. I already have Synapse Studio open here. And on Synapse Studio, we can see databases. For example, on the built-in pool. No, these are on-demand pool. The built-in pool is not always visible. So we see databases on the built-in pool. Let me drop this sample here for Pordenone because we will create it in some moments. So drop it. So we can see the database. Some of these databases are on the on-demand pool and some are on the dedicated pool. And you can see on development, we can see script, SQL script, notebooks for the Spark pools, data flows for the data factory, Power BI connected to Synapse as well. For example, here I have a data flow where the import is a data factory data flow inside Synapse, inside a single tool. So we can do all the tasks inside a single tool. Here I'm importing from an external data lake. I'm importing data from an external data lake. So you'll notice the source option. Here is a query reading data from Azure Open Data Storage. So I'm using ETL to bring data from this Azure Open Data Storage and saving this data on my own storage. Local lake, data lake, weather, and the file name. So I'm saving the data on my own storage. I can use Azure Storage Explorer to analyze the storage. And I have here a lake demo. I will make some examples with this lake demo. My data lake storage, and I use the Open Data Lake as a sample. I use this Open Data Lake as a sample, The data that is stored on this Open Data Lake, the data stored on this place, is from the New York Taxi Drive sample, which is open and available to everyone. Microsoft has some public Azure storage with these samples. So, on the SQL script, I open a script, a demo script, and I will execute this script on the built-in SQL pool, which means the on-demand SQL pool. First, let's execute a simple select, and I'm using the function openRowSet to bring data from the lake demo blob storage. The open data lake, this container is defined as public, so the query is capable to bring the data from this container. So let's use the master database at the moment. So executing, and it's reading the data about trips from the open data lake. The trips, the taxi rides in New York. This is the data about taxi rides in New York. Okay. So I'll create a database. Even on the on-demand SQL pool, I can create a database. New York Taxi Pordenone. So I created the database. Let me select this database. Why I need to create a database on the on-demand SQL pool? To make this query easy, because although I can execute this query, it's not easy to write this query. So I can make this query easier. I can make this query easier by creating an external data source. An external data source pointing to my data lake storage, my storage account on Azure. Let's consider this as a local storage account. It's my own storage account on Azure. So the external data source is created, and I can see this on the database. Let's make a refresh here on the list of the databases. I have here New York Taxi Pordenone. External resources, I have an external data source, Open Demo Malta. And then, since I have the external data source created, I can use this external data source on the openRowSet function, and this makes the syntax of the function easier. I point to the data source and only point to the folder that I would like to read. It's the same than the first query, but now I'm using the external data source to also read the data. So I'm reading the same data about trips stored on the folder trips. But this can be even easier. I can drop the openRowSet function at all. For this, I need to define the file format which is stored on that folder. I define the Parquet compressed format, the format Parquet with data compression, and then define an external table, trips, pointing to the folder trips, the data source, and the external file format. That's it. So I defined the table trips. We can see all these here. External resource, let's make a refresh. The Open Demo Malta, external file formats, and now external table trips. And a simple select from the table trips now brings to me the data from my Azure Data Lake storage. So I'm reading a data lake using SQL. That's a feature of the on-demand pool in Synapse Analytics. Of course, I can process this data. For example, I can group this data. Let's make some processing. Let's count the total of trips according the passenger count. The name of the field is written wrong, but it will work. So the total of trips with 3 passengers, 4 passengers, 5 passengers, 2 passengers, and 6 passengers. So the total of trips according the passenger count. All these I'm querying information from, let's say local storage, the storage account which belongs to myself. But I could be reading information from other external accounts, let's say more distant external accounts. That's the idea that I illustrated of main branch, for example, reading data from each country branches. That's what I call a virtual data lake. So each country branch could continue with their data solution, and then the main branch will consume their solutions. Here we have an example using OpenRollSet. I'm reading from an Azure Open Data Storage. And here there are some tweaks. This query is using some tweaks related to the OpenRollSet. Is using some stars here. There are some stars, some variables on the folder structure, because the folder structure is broken down by year and by month. So I'm telling it to read the folders for every year and for every month. But once I use this star on the path, I can read these parameters. New York City file path, the name of the source, file path, and then I can read this information. In this case, I'm reading the year, the first parameter. And I'm filtering the year. I will get the years only between 2009 and 2019. Filtering the year according to the folder in a data lake make this even more efficient, because in this case, the query needs only to ignore the folders that don't have this year. Don't need to read every record and check the value of a field. It will only ignore the folders that are not from those years. And I will also group by this information and bring this information back. This is a trick to make this query faster. So it took 12 seconds. If I were not using the file path, this query would take way longer, because the query would need to analyze record by record to bring the result to us. The query would have the need to analyze record by record to bring the result to us. So it took only 12 seconds to bring a summary of the rights for each year between 2009 and 2019. This is great. And finally, we can use the serving layer. And the serving layer can build queries over the Synapse on-demand pool and to query the data lakehouse. Oh, but can Power BI read directly a storage account? Yes, Power BI can read directly a storage account, but then the processing will be all a task to Power BI. If instead of reading directly a storage account, Power BI delegates this task to Synapse Analytics, the performance is way better. In this example, I'm using a data flow. So I have a data flow built on the server. Let's edit here. Edit this data flow. Taxi rides flow in Power BI. So we can take a look on the details of the source. And advanced options, and we can see that we have a query which is being executed over the Synapse on-demand SQL pool and using open row set to get the data from the storage. So it's using the on-demand SQL pool to get the data from the storage way faster than if Power BI were reading the storage directly. And the report provides the result, a simple result. Something very simple. I'm breaking down the data by month, by each month of the year. I have not elaborated too much the report, just breaking down the data by month of the year. Okay, so with this demonstration, we just saw that using Synapse Analytics, we can go from the data factory, import the data, process the data, and in this case I used a on-demand SQL pool and even reading data from external places, I mean places beyond my control, like the Microsoft storage account, for example, what I call a virtual data lake. I have not illustrated the on-demand SQL pool capable to process relational data or the Spark pool, also linked with Azure ML, capable to process ML models, and all these inside the Synapse environment. And Power BI is also linked here inside Synapse environment. My account is not perfectly configured, so we can see the report, but I can't open the report. My account is not perfectly configured for that. But we can link Power BI here, and we could even create new reports here. Let me close this. Again, my account is not perfectly configured, so it's not showing the option to create a new report. But I can create a new data set. For example, I could create a new data set, but as I said, I have some configuration issues with my account. Okay, so with this we are illustrating how Synapse Analytics is capable to help us to build an entire data platform from a single tool and going from a simple data warehouse to a virtual data lake house and building all the steps of this data platform. Any questions anyone would like to ask? Any questions? We have some minutes for questions yet.
Thank you, Dennis. Thank you very much for your very interesting session.
Thank you very much for inviting me to talk on this conference. It was a pleasure to talk on this conference, and I leave to everyone my contacts. Feel free to keep in touch. It will be a pleasure to stay in touch.